Hello, everybody. This is Bacter, and welcome back to Elle's Heart.Break. I'm very glad that you decided to join me. Last time, if you remember, we kind of stopped doing our job as a crappy soda salesman, and we decided instead to start changing the world because we discovered a modifier. And then we discovered a second modifier, and we used one to modify the other and to remove all of its restrictions. And now we have an unrestricted modifier, and part and parcel with that, we've discovered sort of a deeper truth about the universe, which is that at least in this city, in this world, everything runs on code. And we, being an industrious hacker, we now have access to, uh, you know, the world, the ability to do lots and lots of things. And so I asked everybody what we wanted to do next, and opinion was divided as to whether we were going to spend our time enhancing our capabilities, finding out what was out there, getting our bearings on the code and how it may be manipulated, or starting to have some fun hacking us some money. Um, uh, you know, just doing what we can, getting into different areas and things like that. So I think that all of those are fine ideas. Again, the gloves have really come off at this point, and I felt very differently about the game at this point. I stopped feeling like a lost tourist and started feeling like someone who was truly curious about the world that they had been put into. Okay, so much for that. So, we're going to do a couple different videos. I'm thinking three to start off with. One of them is going to be more of a one-off, and the other ones are going to be ongoing chains. One of them is just going to be an explorational video where we do a tour of the city and just kind of see what else is out there. Could be cat-like eyes. That's kind of crazy. The second one is going to be code-based, where we talk about how to program in Sprock, which is the name of the programming language here. I think I figured out because Sprock sounds a bit like Sprechen, in German. Speech, right? It's just language. I get it. Um, and then the third is going to be let's actually do those things and mess about in the game world. This is the first video of the what is programming, how do we program, what do things look like, and what kind of code is out there series. So let's go over a few things just very briefly. You've seen these disks around everywhere, these floppies, and you know that we've been able to put them into a floppy reader. Now, a floppy is a special object. I can hack it, and you see that there's code, there's just, not code, pardon me, just text on it. If I try to compile it, and the compiling is saying, do you agree that these are good instructions, it compiles, even though I'm here to tell you these are not correctly formatted lines. If this was a real compiler that was really worried about formatting, this would immediately fail. It would go, I don't know what one means. I don't know what smoking means. I don't know in what. That's a special word. You see this apostrophe, this open. It's meant as an apostrophe, but in the computer would read it as the beginning of a quote. So it's like, oh, the rest of this is supposed to be a string of characters. I don't get what you're doing here. But a floppy is not read. It's a special kind of thing. So basically, you take this, you feed it into a floppy reader, and it outputs, whatever we have here. So just do crimes, hack the planet, government is bad. Yeah, I feel that encompasses what the basic premise of the Resistance so far. So this is our IDE, or Integrated Development Environment. I think I misspelled it there, but whatever. Integrated Development Environment. And this is something that programmers will really use. You want a place to type in your code, you want a place to compile it, and it's nice if you have some extra features, like if you can reset everything that you've done, or undo the last thing that you did. So, the code is read from top to bottom in order, and every line is meant to be an instruction, which is done by the computer. Now, let me talk briefly about what Sprock is. Sprock is what we call a high-level language, and this will be reviewed for any other programmers out there, but the basic way it works is we would like to make a computer do things, but computers don't speak English. The way that their circuits work is in terms of binary until we get quantum computers. So that's ones and zeros, basically. Uh, And so the machine level instructions, the most basic kind of code, are ones and zeros. And in fact, if you know how to do it, you can write ones and zeros forever, and it will run on a computer, and it will do whatever you want it to. You could technically write out all of the ones and zeros and run just about any program you're thinking of. Nobody does that because it's insane. People are bad at learning ones and zeros. So we wrote a translation program, basically. And the translation program takes a slightly more readable language that we call assembly and translates that into the ones and zeros. The problem is assembly itself isn't particularly readable again. It makes a little bit more sense. They're like kind of words in English, but they might read something like extern printf section dot data db hello world comma 0 db %S100 section.text global main. These are all particular instructions which are easily translated into ones and zeros that the computer can read, and they make the computer print out the string hello world. Okay, but nobody wants to learn that either. Well, fine, so we take the final step and we write what's called a high-level language. This stuff is generally pretty readable. In a high-level language, gets translated into a mid-level language, which is assembly, which gets translated into a low-level language, the ones and zeros. So rather than learning ones and zeros, we all just have to learn the conventions of a regular programming language. And happily, I will say I have not programmed much in this game or ever in Sprock because it's not a real language. I grew up doing Java and C++, and these days I mostly do Python and R, and I guess some Perl if I'm forced to. And those are all high-level languages. They're all good at different things. MATLAB is another one that people frequently use. And the really nice thing is once you learn one of them, it's much, much, much easier to learn the rest of them. So, I said before that floppies were not really set up correctly, and that other things might be. So let's just type in some gibberish and try to compile. Look at that, it complains. It goes, I don't know what A means here. I don't know, this is just gibberish text. If the computer will never know what you mean, you have to type in things perfectly. So let's say here we have, if we try to use this door, then it will, is print on here? No, but let's try say, howdy. So this is something we could do. Alright, so let's try to open the door now. Oh, I guess it still took us. That is very odd. Oh no, it didn't. It always makes the screen blank out, which is kind of funny. But instead of taking us anywhere, the door says howdy when we try to open that. And that's because I ran a function on the door. Okay, so when I say every line is an instruction, I mean it, unless the line starts with the pound sign. Then that means the program recognizes that you're having a comment, which means ignore this, and you can type whatever you want here. And the nice thing about that is, if you have like some long bit of code below it that you want to explain, and you should always comment your code, then you can write below, makes the door say howdy. And so then we'll say howdy, and then it'll do that thing just like it did before. I'm going to open it, and the door say howdy. All right, easy enough there. So now we can just kind of program it to make us do whatever it's want. Its default command is go to, and it's very clear what happens there. Now, obviously, there's some other stuff going on behind the scenes that we don't have access to right off the bat. You saw that with the floppies, because they didn't even try to compile anything. It didn't matter what we typed in. It just, held some text. It was basically working as a notepad or a word program. Here, whatever function we tell it to do, it always does a little fade to black on the screen. So obviously we don't have full access to everything based on our modifier, at least at this time, at least in this way. If we take off everything, then nothing happens. Right. What else we can do are just type in different functions. And so then there's really two things that we're going to be working with. The first are variables. And so we know that there are a couple of different kinds of variables. There are numbers, and numbers are what you'd expect, 1, 2, 3, 4. And, they behave differently. You can add numbers. So number A equals 1, 2, 3, 4. Number B equals 2, 3, 4, 5. And I want you to say A plus B. Let's see if that works. Okay. And now let's open the door. I should find a better way of doing this than... Hey, look at that. 3, 5, 7, 9. So it added those and it said the result of those. Okay, so in this situation we have two things going on. First off, we were able to tell the program what A meant when we say it and what B means when we say it. And if we don't tell them that, by the way, if we don't tell them what A and B is, look, it flips out. It goes, look, man, you're telling me to say A plus B. I don't know what A is. I don't know what B is. So we have to tell them what it is. I think probably in Sprock it will do some automatic typing, which is to say it will not require us to say number? Oh no, it actually does. Okay, so if we're going to define that, we do need to say number. Doesn't do automatic typing. Good to know. So there we go. And that's if we want to have a variable that we use later. So let's say, will it say 1, 2, 3, 4 all on its own? It will. It'll say a number. So the other thing that we can have besides a variable is a function. And a function is a set of instructions that are really they package up a bunch of functionality. So when we say say hi, that means it takes care of a lot of overhead for us. Like if there was a whole series of things that I needed to write a lot of instructions to get the word hi to get output to the screen, I don't have to do those every time. I can just encapsulate them and call it this. Can I define my own method? I think I can, but we'll have to talk about that later. You can sort of define your own, and then if I define my own, like let's say that this was the way to define a method, and I don't think maybe is it def? Or is it define? Well, regardless. There'll be some way that I can set a method. So, let's say we have a method called A, and I say it takes a string. And then, this probably isn't how you type this out, but then I say print A, and then print A plus other string. Then anytime I called A, if I called A on the string, the first string, then it would print out, first off it would print A, which is first string, and then second off it would print first string other string, just like that. Basically, it's just a way of doing a lot of instructions all at once. I don't know if that was the best example, but hopefully that was relatively clear. So one of the first things I think would be very interesting to do, to note, is that it looks like different objects have some different methods associated with them. So let's say we learn a bit about what methods are out there, what we can affect, and what all they are. So there's some real basic ones. The suggestions here all have to do with hello? Who are you? I'm going to talk right now. Alright, that's fine. I'm just going to be here hacking, so you do your thing, lady. The methods here all seem like they have to do with what are called arrays. So let me back up a bit to what we were doing before. There's a couple kind of variables. There's number, which is like 1, 2, 3, 4. There is a string, and a string is the computer's way of saying text. So in other words, if I had 1, 2, 3, 4, and I should define what these are called. So number A equals that, string B equals that. If I tried to, if I tried to say like, say B plus 12, I think this is going to complain because you really shouldn't add a string, which is just text, to a number. Is it? Oh, it does that. Well, what the? Is it going to say 1, 2, 3, 4, 12? It does. It says 1, 2, 3, 4, 12. Fine. So it converted 12 to a string here and set it out. That's fine. Notice, though, by the way, if I said, say, A plus B, and this was a number, and then B was also a number, B was like 2, this would have then printed out 1, 2, 3, 6. because it added the two numbers. A string is just text, so when I said, A plus B, and B was a string, and then I said, so 1, 2, 3, 4, or I said B plus 12, it converted these two numbers to a string and just appended them onto the end here. Okay, so much for numbers and strings. So again, who are you? Oh, are you? You're that the professor, the visiting guy. Hey, Guten Tag. Yeah, you are German, weren't you? Guten Tag, Tschüss, buddy. How's photography? I am interested. Great. You're going to be part of the resistance or something, aren't you? I saw. Well, that could just be his bad accent, I suppose. Well, I'm going to have to head down to the harbor and take a look at that bird, buddy. I'm very interested in that. I'm not selling anybody any sodas anymore, by the way. That's not my life. I'm no soda salesman. Alright. So much for numbers. So much for strings. And, there's different... part of the reason to call them in these different ways are there different things called operations that you can do with each of them. So if you have two numbers, we can do a times 12, a plus 12, a minus 12. And it's understood what those mean. For strings, there's different operations. About the only one you can do is... So what if we did b plus 12, then it converted 12 to a string and added that to the end. B minus 12, I think, is going to... It's actually going to be okay. Alright, well, what do you say when we try to say b minus 12? How does that interpret? No, it blows up. See, there we go. Because it doesn't... It has no idea, right? Look at this. It can't convert value. Howdy. Of type string to number. Can't access value. How you've forgotten to return a value. So, look at that. Didn't know what to do. Didn't know the operation. It compiled, which means that the compiler didn't find anything egregiously wrong, but then later on, when it tried to run the instructions, it found it wasn't able to. Fine. The last kind of thing that I'm going to talk about for now is called an array. And an array is just an ordered set of things. It can be numbers, it can be strings. So, let's say that we have something like this, and we'll call it array AR equals this. Fine and dandy. Oh, by the way, in most programming languages, it can work different ways, but my guess is it won't let us say AR before we've defined AR. Let's see. Yes, indeed. It does things in order. So before we define what AR is, we can't print it. So, say AR. Are you happy now? Yes, you are. Now, if we open the door, it says 1, 2, 3, 4, just because that's in the array. Okay. Well and good. So, this is an array, and it's an ordered way of keeping things. It's an ordered way of keeping values. And I don't know if they let you mix types, but let's see. Yeah, it looks like there's no reason not to. So, an array just has... And the whole point to an array... will you not... Did I take off the say command? Why are you not... Oh, no, you will. I just had my mouse over it. Yeah, 1 high 3 4. Neat. The point to an array is that you can access things at any position. So if I said array 1, I don't know if this is how you access it. This is how you would access the elements of an array in lots of different languages. Let's see if it works here. It is fantastic. This is what I mean. Once you know how to program in one language, it's easier in others. So, basically, this is what we call zero indexed, which means to say the index numbers start at 0. And so array at position 0 is whatever is right here, and this is 1. Array at position 1 is high, array at position 2 is 3, at position 3 is 4. Array at position 4 is going to blow up, I think, because, and I don't want print, I want say, it's going to blow up because there's nothing in position 4. So, let's open that door and see what happens. Yep, look, it's the door is on fire because of the bad thing we did. Doesn't know what that is. So, that's an array. They can be very useful for holding values. The nice thing about this is, if you have a whole bunch of things, if you have like 20 values in here, you don't want to have each value held in, number A, number B, number A1, number B1, A2, number A3, number A4. No, you can just have array A equals 1, 2, 3, 4, whatever, or A, B, C, D, or whatever you want to have there. It's just easier to access and it's easier to work with. Arrays are very popular for a very good reason. Oh yeah, just a quick note about naming things. My guess is that this is like most languages. They won't want us to call something 1A. Yes. So, they are fine with the name A1. They won't be fine with 1A. Generally, if you're naming a variable, you have to start with a letter. Just a convention that makes it easy. Okay. So let's take a look at some of these functions then, shall we? We have say, which obviously just prints something to the screen. Easy enough. Count. Notice if you type in the beginning of the function, it'll give you a nice little description of it here. So count just how many values are in the array. So let's say count AR, and this should be 4. Yep, there we go. Okay, count, easy enough. Range. Create a range of numbers from min to and including max. So say range 1, 4 is going to print out 1, 2, 3, 4, just like that. Easy enough. Okay. Get index. Get indexes. Create a new array that contains the indexes of another array. So let's get indexes of AR here, and let's say that array and they're called 0, 1. What are they called here? 0i, 1i, 2i, 3i. In other words, these are indexes, and the deal there is, if we want to access those, so let's say let's do something here real quick. Let's say we get we want to take the index, so we can create. Let's say we have a new array, ARI equals get indexes of AR, just like that, okay? So now ARI is an array with the indexes from R. So let's say that we do, say, ARI 0, and let's try, say, ARI 0. See if all that works. What do we not like here? Oh, there we go. Gotta get your brackets right. Alright, let's see what happens there. What did it not like? Tried to do something it didn't like. Huh. Weird. Anyway, I tried to say 2 things, and then it always overwrites the last ones there. But so let's comment this out. You saw that say ARI 0 produced 1, and let's just take this thing by thing. Yeah, it keeps having something to say to me up there. Okay, so if we go ARI 0, that's the 0th index of the array ARI. That is like 0i. It's an array marker. It's a pointer to a position in the index of this other array. This might seem kind of arcane, but it can be very useful to have this, especially if you're not just going in order, but you're finding arrays or indexes that match a certain set of conditions. So basically what we've done here is, for each one of these positions in this initial array, there's an index that points you to it. Now, we were able to get to it very easily by saying, like, AR0. And that says, okay, take me the 0th, whatever's in the 0th position of this array, and that's here, it's 1, okay? Whatever is in the first position, we're able to do that, and that'll give us high. Whatever is in the second, third. But when we type in that, it says, okay, when it says, AR1, that says it's this index is what we're pulling out here, and we could actually deal with that value directly. We can create another index that just, or another array that holds all of those indices, and we saw that they're called like 0i, 1i, 2i, 3i. And then if we can access that value, we can just use it to get a value from the original index, or from the original array, excuse me. And again, that's something which might be useful a bit later on in programming. It's just neat to know that we can do it for now. So we can get things both by just naming their position or by saving their index number. Okay. Append is really easy. That's just a way to add something to the end of an array. So if we've already set AR to be this, and we want to make it so that it's 1 high 3 4, then, or 1 high 3 4 5, we can just say like AR equals. Actually, I don't know which way it is, so let's try this. Let's say that I don't want to mess with all this, so let's say array AR equals 1 4. Okay. Now let's try append AR4, AR3, and say AR. There's two things that could happen here, and I'm actually not sure which one it is. The array AR at this point is either going to be 1 4 3 or just 1 4. The reason for that is this differs in different languages. Sometimes, if you run something like this, it actually modifies the array AR. It'll change it, and sometimes it doesn't. Sometimes you would have to say AR equals append AR3 in order to actually change the value. This is like an in-place change, I think is what they call that. But let's see which way is it in Sprock. Let's see. Did I not tell it to say? Maybe I didn't. Oh, look, I'm getting sleepy. Look at this. Well, let's futz with something here real quick. Let's pull out our coffee. Let's hack the coffee. Sleepiness minus 25. No, no, no. I want sleepiness minus all the sleepiness. Minus every sleepiness. Drink that coffee. Oh, we are jolted awake. Yeah, no more sleepiness at all. Fantastic. Okay. I don't understand why it's not saying something. That's the weirdest thing. What happens if I take this off? Yeah, there's 1 4. Let's try this. No idea why that's not saying it anymore. Did I not do append right? Maybe you're supposed to change the order of those. Array and element. No, it's supposed to be AR and 3. Well, let's try. See if this works. Oh, what didn't it like? Undefined variable AR2. Oh, fine. Yeah, fine. That's an array. What? Oh. What? Why did that happen? Did I press reset by accident? I bet I did. Fine. I think I used a period as opposed to a comma there. Okay, so for some weird reason, It's not letting me append. Can I do type? It's not letting me append and then output the result of that to. I have too much. There we go. Man, I don't know what in the heck is going on here. We're gonna have to do a little bit more investigation of this one. So theoretically, at least, append should just put an element to the end of the array. So AR is the array. The element is 3, right? So can I not? What happens if I say that? Weirdest darn thing as far as I'm concerned. Alright. Again, if I say AR at this point. Yeah, says it. No idea. Alright. Well, we're going to have to investigate that a little bit more further. So we've got range, remove, so remove and remove all. Just take things out of the array like we've seen before. Get indexes gives you the indexes of an array like we've seen. Has index, so has index checks to see if an index is in the array. So that's to say array AR right now is going to have an index at 0 and an index at 1. So let's do has index AR 0. Oop. What don't you like? Too many parentheses. There we go. I should say true. It falls right with the world. It does, because we have an index at position 0, but if we go has index AR 5, well then, it doesn't. Alright, easy does there. So, yeah, that's has index. Okay, we've got append, type. Type just tells you what type something is. So say type AR. This will say index, for instance. Yep, it's rather than index, it's an array. And if we then later said number AR equals, yeah. By the way, you can redefine things if you want. So if our next value here, it doesn't let you rename. Fine. That's handy, I suppose. That's one way to deal with figuring out what type things are. It's just to not let you redefine things. Only one definition of a variable, please. It's not always the most elegant thing, but it works in a situation like this. So AR2 is a number. Easily done. Alright. Round. That just rounds a number to the nearest integer. So round 1.2, it'll say 1. Easy enough. Okay. Int, remove the decimals of a float. Alright, so one final kind of number is a float. Guess you can't declare. I guess everything is called a number. So a number is either int or a float, and an int equals 1, 2, 500,023. Anything with no decimals. A float has decimals, so 2.409234. That's a float. And so if you declare round, no, if you declare int 4. Then it will call that 4. My question is, does this not round? So what if we said, say int 4.93, etc., etc., etc. It's 4. Fine. So it only looks at the first digit. It doesn't care about rounding. Easily enough. Okay. Now then, mod appears to be next. Get the remainder. Ah, that's modulus operator. So, in other words, if we take the mod of 2 and 4, say, mod of 2 and 4, then what we find, the answer is 2. And the reason is 2. So this is the of x divided by y. So the mod of 2 divided by 4. What's left over when you divide up 2 into groups of 4 are 2, because 2 doesn't divide evenly. So what would be the mod of 4 and 2? Why, that mod ought to be 0. On account of, yep, on account of you can divide 2 into, you can divide 4 into groups of 2 evenly. So, you can figure this out one pretty well. So 11 and 5, mod should be 1, because you can get to 10, and then there's 1 left over. Right? Easily enough. It's just a simple arithmetic operation. Lock locks the door. Okay. And, look, it needs a security code, so that's interesting. Unlock, it does somewhat the same. There we go. Okay. Go to, we know that one already. That walks out of another door, and we need a door name for that. Easily done. Get user. Interesting. Get the name of the person using the door. So, how about, whenever we use this door, it will say get user. And you notice this is a function which doesn't take any arguments, which is to say, you just type in the parentheses open and closed. So let's open the door and discover that our name is Sebastian, as we might have expected. Don't know if we can disguise ourselves yet, but that's what we have. What is stop user? Stop the person to walk through the door. Okay, so I guess this means let's try something real quick. So this says, oh, we've reset it to hotel bathroom door to corridor. I think what we want is room 1, door 1. Is that right? I think that is what we want. However, let's try a little something right now. We're going to do what people call an if, then, else loop. So, if, and basically we just have our conditions. We say if condition X, then do something, then do we, no, if condition X, something else, something else. Basically, it's like that. It's easy enough to understand. So let's try if get user equals Sebastian. Stop user else go to. Oh, and if you're going to have a loop like that, you need an end statement. Got it. All right, let's try this. Let's just see what happens here. Yeah, look at that. It doesn't let us go through. Okay, so otherwise, let's take all this out except for go to hotel room 1 door 1. Haha, that's pretty neat. All right, so that's something that we can do now. We can stop particular people from going through doors. Good to know. Okay. I think we're sort of finishing on here. Stop user, say we already know. Sleep. That means pause the program for a number of seconds. So say hi. Sleep for 4 seconds. Say bye. You saw before, if I tried to run 2 say statements, they just overran each other, and you didn't get to read the other one. But this is hi, and then bye. And I think I was kind of covering it there a bit, so hi, bye. All right. Say sleep, disconnect. Oh, that's interesting. Remove all connections. We don't know what that means yet, but there are some connections. Connect. Connect to something. Connect to Sebastian. How about that? Do we like that? No, we don't have a variable or a function Sebastian. Okay. So we can connect, we can disconnect, and remote function call. Call remote function on connected objects. Function remote control. takes a receiver index, a function name, and arguments. Okay. Well, there we go. That is good to know that that's what happens. It's interesting, by the way, that this thing defaults to what our thing was broken to before. I wonder if that means somebody had been modifying our door, and then, sort of in a panic, caused it to reset. Well, regardless, that's a fine little introduction to Sprock. This, I think, will be video 1 for let's walk around and find out about what code does. We did a lot of function looking, and I'm going to keep sort of a running tally of the functions, so we'll keep that in the thread, but thanks for tuning into this one. I will catch you guys next time when we do a little bit more exploring.